Hello and welcome to The Medium is the Message. As is evident, I am Stephanie Brenham, and I will lead you through this presentation on how the wider context and the different production types shape the tech we create. My title is in honor of fellow Canadian Marshall McLuhan, a communication theorist who coined this phrase, "The medium is the message." It relates to the symbiotic relationship between the message you wish to convey and the medium through which the message is transmitted. In the context of the internet and ChatGPT, it's important that we check our sources. So I wanted to give you a quick overview of relevant highlights of my career. I am currently the rendering lead programmer at Ubisoft Toronto. As is often the case in games, I am currently working on an unannounced project. And that means I can't tell you what game I'm working on. My team owns the visual systems of the game that are responsible for rendering the artistic vision of the game to the screen. We keep a close eye on the performance and work diligently to optimize the use of graphics hardware. I was the rendering team lead programmer on the game Far Cry 6, which is an open world game, and it's in a tropical island. It's a lot of fun if you want to pick up a copy, but that's not why I'm here. It did win a Navgtr for outstanding graphics in 2021. Before that, I actually took a break in my career for 6 years. And in my previous lifetime, I was on the rendering team of Maya, as was mentioned. I brought leadership to the rendering team. If you have never heard of Maya, it's pervasive in the film and VFX industry. In fact, it won an Oscar in 2003 for its vast technical contributions to the film industry. Ooh, we're gonna have to scroll down for my notes, but I can tell you from memory, because I did this, my first job was actually at homeproject.com, which is back when companies bragged about having web pages. I want to start this talk by setting the stage and giving you an overview of what I'll present. I've worked in a lot of different types of productions, from small startup companies to international AAA games companies. I have found there is a commonality to all these different development environments, and that is based in the types of questions we should be asking ourselves. Because the quality of the tech solutions we create is directly related to the quality of questions we ask ourselves. We don't operate in a vacuum, and our tech needs to match the wider context. From research to software products to games and game engines, the code needs to match how it will be used. Throughout my talk, these icons on the side will be your guide as I lead you through the presentation. We'll start with looking at the critical importance of asking the right questions. We'll then follow these ideas through to what makes research unique and how research bridges over to software production, which focuses on shipping products to customers with its regular release cycles. I'll then take you over to video game productions that live and die by the fun players have. And we will wrap things up by looking at game engine development, which has some interesting tiebacks to software production. I have focused my career on rendering and computer graphics. So let's start with a story about a fun little phenomenon, chromatic aberration. The different colors of light have different wavelengths, and because of that, the focal distance for each color is a little bit different. The result is the prism effect that we are all familiar with. The uses of chromatic aberration in graphics are wide and varied because the look can range from the dramatic and striking, as seen in images like this. The color's a bit better on that if you want to look. But that's just me being picky about color probably. As well in film and VFX, this is used because it also shows more subtle color fringing. on objects, and it's used for a variety of narrative and artistic reasons. It's a very important effect to have in an image. Even still, when I was working on Maya, this effect was generally not included in the 3D rendering process. However, during my time on Maya, chromatic aberration was added as a feature to one of the big film and VFX renderers. Interestingly, the reaction to this feature in the film and VFX industry was kind of a big ho-hum. Why was such a universally used effect being overlooked? It all relates to the customer workflows. The customers would set up the data during the day so that overnight a render farm of hundreds of computers would take all night to render out the needed images. Once the rendered images were produced, post-effect artists could use a product, like Nuke, to tweak and tune the images. As you can understand, iterating on the final renders took many hours as it required waiting for the results of an overnight process. In contrast, in post-effects, a single artist can iterate on images in a matter of minutes. The goal of every studio was to do as much look adjustments as possible in post-effects. As it turns out, chromatic aberration is one of the easiest things to fake in post-effects. By moving chromatic aberration to the 3D renderer, the film and VFX studios would have dramatically worsened their iteration time. The new feature didn't make sense when you look at the wider context, which is why we always need to be asking ourselves key questions. When starting out, the most obvious question to ask ourselves is, what are we trying to create? It's kind of a basic. Over the course of my career, I've come to think of tech as a service. Our tech is a system that supplies a need. But I've focused my career on creating not just any type of tech. I've focused on bringing art to people through tech. Creating tech to service art requires extra investigation and proactive information seeking. We can't just rely on our experience as programmers to give us insights we need to create innovative solutions. This has forced me to think explicitly about the process needed to build collaborative, cross-functional teams. For these teams, we need to think about the questions who, what, how, and why. More explicitly, who can represent the client perspective? What is your tech supposed to do? How will it get it done? And why should your tech do that? In this context, when answering these questions, programmers and research scientists supply the how. We determine how the tech will be implemented and how it will run. Clients provide the what and the why. Now, ideally, clients specify what should be implemented. But as we all know, sometimes it's not feasible to do exactly what the customer is asking for. Because of this, we need to understand the customer's motivations when looking for alternative solutions. And who can speak to the client perspective? Well, that all depends on your development environment. As we go through this talk, I'll call out who is the client in the different scenarios, and some techniques for getting the right people to speak to the client perspective. I have found that programmers and research scientists are really good at investigating the what and the how. We are trained to request clear specifications of what our tech should do, and the tech owner is required to speak to how the implementation works. But I find in our circles, the why is often overlooked. Answering the question why requires an understanding of client motivations and workflows. In the example of chromatic aberration, the developers should have stopped and asked, will this feature improve the customer workflow and why? Sure, The more accurate chromatic aberration from a 3D renderer is nice, but when faced with tight deadlines, accuracy just doesn't mean that much in the film and VFX industry. I propose that the question why is also more than just finding motivation for feature development. For me, it's one of the most fundamental yet mysteriously overlooked questions we can ask ourselves. Here we have a slightly modified version of some code taken from the open source Godot game engine. I've removed only one line. If this is how the code was written, no one could fault the code. It's as clear as day what this code is doing. In particular, these 2 lines are clearly ensuring the modification stack is operating on the correct skeleton. But nothing in these 2 lines of code stands out as critical. The code just reads as regular defensive programming, whether you know what a modification stack is or not. That it works on the right skeleton makes sense. But see the difference when I add back this simple comment. Needed to avoid the issue where the stack loses reference to the skeleton when the scene is saved. This comment gives us the extra context we need to understand why these 2 simple lines of code are critical. As well, this comment instantly deepens our knowledge of the wider context of the Godot codebase. We're looking at the code taken from within the animation systems. Without this comment, I would not anticipate that saving the scene could possibly break the animation systems. This example shows how seemingly unrelated systems can have implicit secondary effects, and this is imperative to understand if you're going to be making changes in a large code base, like Godot. As shown in the example code from Godot, even small functions will need to take into account the wide code base as a whole. And with the comments removed, some people would even describe the previous code snippet as self-documenting code. It's easy to read because it uses descriptive parameter names and familiar patterns. The code clearly shows what is being done. But we can't get rid of the need for comments. Hidden in all of this is the need to regularly ask ourselves why when coding. Is it the case that there were alternative algorithms that could have been used to implement your work? Why was this implementation chosen instead of the other alternatives? Are there specific lines that are needed to prevent issues? Why? Comments are meant to document the reasoning behind the code, or, as I tell my team, code should show what, comments should show why. Here's the thing about why. Clear reasoning doesn't just rely on opinions. As much as possible, use data to inform the decisions you make. It's easier to understand the rationale of a decision when it's based in relevant data. As well, using data helps protect against the impact of personal biases that can affect us, especially in high-pressure situations. For example, you should be very clear on the why when triaging issues in time-critical moments. When there is a limited amount of time to fix public-facing issues in your work, you want clear reasoning to guide your decisions. In situations like this, there are 3 pieces of data I use for deciding how my team dedicates their time. The scope or the risk of a fix. Is this a quick, low-risk fix? I'm more likely to find some time to squeeze in a fix for that. Whereas a risky fix, that can cause more harm than good. And I need to be very clear as to why the risk is worth it. So I also look at the impact on the affected customers. Does this issue completely block the customers? Or is it just considered a mild annoyance? And what is the percentage of our customer base that is affected by this issue? I promise you that an issue that affects the vast majority of our customer base will immediately catch my attention when I'm triaging. I'd love to see the rest of my speaker notes as possible. We might want to squeeze that font down a little, but it looks like I'm basically wrapped up. It was just to say that this makes sure that my team is focused on the best customer experience, because it's clear why some issues need to be prioritized over others. Why questions are aimed at determining the motivations and the reasons behind decisions. Why gives us a purpose. And without purpose, people can get lost. When I think of people without purpose and getting lost, I think of this story. So for years, my husband was in the Army in Canada, in the reserves, and he would often go to be a part of Army exercises. On one of the exercises, they were waiting for trucks to arrive from different locations. One of the trucks was late, so they radioed to the driver to ask the truck's location. And the driver cheerfully responded, "Geographically challenged, but making good time." But the thing is, when you're making tech, or say driving a truck filled with Army supplies, you should always know if you're getting closer to your goal. So if you have no idea of where you are, or if you're headed in the right direction, just stop and get your bearings, because high velocity in the wrong direction can be a big old waste of time. With that story in mind, I propose the question why should be thought of as the North Star. It gives us purpose as we adapt to new discoveries and changing circumstances. Because our difficulty is that we can't plan for everything. In life and in tech, the path to success is not a straight line. And as shown in research and prototyping, you don't need to have all the answers when you begin working on a tech solution. In fact, many of the right answers are learnings you pick up along the way. To balance, there, I got the mic back. Okay. To balance the risk, I recommend having checkpoints to stop and compare against the North Star. This gives you a chance to course correct as needed, which means as our planned feature set may adjust and change, use why to ensure that your work is still relevant to customer needs and that it respects technical constraints. But enough about general circumstances. Let's look at some of the more specific contexts you might be working in. I've worked with several research departments over the years. As a part of Alias Wavefront and Autodesk while working on Maya, and also as a part of Ubisoft. I have experience with research teams across industries and decades. To help frame some of the discussion, I'll contrast the research environment versus the production environment. In research, the goal is to figure out if ideas work. The research is usually aimed at fitting into the company's tech ecosystem. For example, a video game company is unlikely to invest heavily in research aimed at medical science. In research, iterations may be fueled by new ideas, but the goal is to reach a conclusion so that the work can be integrated into a product or a game. In contrast, production has specific markets in mind for gaining profitability. And the goal is to be cyclical in nature. We don't want to go to the trouble of creating a code base just so we throw it all away every time the product is released. And because of this, In production, we need solutions that scale over time. And that, in my experience, research has production as a client. Because research, I switched the slide on you. I figured the notes weren't that needed. Has production as a client. Because research departments aim to have their work integrated into a product, you could say that the dream is to spark the imagination of someone on production who can evangelize the work to the rest of their team. It's critical that research departments help production teams understand how to integrate their research into a product, because the production team is the one who is responsible to bring the vision to life. And if no production is interested in integrating the results of your research, then you may be looking for a way to make your idea more compelling. The most successful research projects I've seen have a lightweight relationship with throughout the production cycle. No one remembers what happened months ago. So have regular checkpoints to catch up with each other and get to explain new and exciting developments. I'm also a big fan of having clear ownership, especially when there's transferring between teams and a gray area. When it comes time to integrate the work into a production, you want people who don't care if it's a problem with the research side or the production side. They just care that the problem gets solved. And a good way to do that is to pair up a person from research and a person from production, so that these people own solving problems and not pointing fingers. As you can see by the icon, I've categorized this as research. But prototyping isn't quite research, and it isn't quite production either. Prototyping is usually production's way of mitigating risk for unproven ideas. It needs to be flexible and process light, because the goal is to prove ideas. You don't need more rigorous things like full automated test frameworks that slow down short-term productivity. With prototypes, the emphasis is on rapid results, not robustness of solutions. Commonly, prototypes are driven by the constraints of the wider production code base, and usually used for two main cases. Is it unclear if the particular algorithm will work in the current code base? Then you might want to use a prototype. Does the idea need isolated testing outside of the complex code base to prove that it will work? Then prototyping is just the thing you're looking for. Like research, prototypes are not meant to be iterated on. Prototypes are meant to feed into production. And in production, the proof is in the pudding. Now, from a personal perspective and for your resume, you can most certainly gain things from working on a production, even if it is canceled and never ships. But from a wider company perspective, products don't mean anything until they've shipped. It's often said that 80% of the stress is in the last 20%. For contrast, in research, you can gloss over the parts that are not related to the idea that you're exploring. But productions need to speak to every decision they make. And the value of the decisions you make at the beginning of production often isn't evident until you're shipping. Productions need to take cool ideas and turn them into fully realized products that match customer expectations of performance, ease of use, and stability. While the emphasis on prototypes is rapid results, the emphasis of shipping a product is robust solutions. My most impactful experience developing software product was working on Maya. I call Maya a career software because people build entire careers using primarily Maya all day long. In comparison to a casual user base, Maya customers are more willing to accept complex workflows in order to achieve exacting results. Because in film and VFX, directors are hired for their ability to have compelling and exciting visions. So if you can match that vision down to the details, you have just become a prized member of your production. The extensive use and reuse of Maya workflows throughout the day means that customers are greatly impacted when you make changes. On Maya, if you reduce a workflow from 10 clicks down to 3 clicks, and that's a key workflow, poof, you've just become somebody's hero. While I was working on Maya, we had an entire release that was focused on improving workflows with minimal new features added, and this release was well received by our customer base. But there is a risk to having a passionate and dedicated user base on a large established product. For a product that has been around as long as Maya, almost anything you do seems to break someone's critical workflow. This XKCD comic made all the rounds on Maya when it first came out because it rang so true for us. And many thanks to XKCD for giving me permission to include this comic in my presentation. Let me read the key parts for you. This comic shows an update to a user forum that states the CPU no longer overheats when you hold down spacebar. The first user comment is, "This update broke my workflow. My control key is hard to reach, so I hold down spacebar instead, and I configured Emacs to interpret a rapid temperature rise as control." The summary at the bottom states, every change breaks someone's workflow. So the challenge when working on a product like Maya is that even if your change is a net positive, you will have some customers that rely on old behavior. Luckily, a certain amount of this can be mitigated by adding user preferences and options. But when it comes time for major overhauls and refactoring, eventually you have to make the decision to leave some users behind for the health of the continual evolution of the product. And we did exactly that when we released a version of Maya with all those workflow improvements. Interestingly, this type of problem shown in this comic doesn't just happen with features. It's a well-established phenomenon with public APIs too. Our customers are resourceful and will use whatever tools they have available to them, even if you didn't tell them the tools were there. Hiram's law states, with a sufficient number of users of an API, it does not matter what you promise in the contract. With time, all observable behavior of your system will be depended on by somebody. In practical terms, that means that your public API is being used in ways you never even imagined, which makes it particularly interesting for when you get support requests for workflows you didn't even know your product could do. One of the ways to minimize the many divergent and creative ways that a customer can use your API is to develop a golden path. A golden path in code is a clearly established, singular way of accomplishing certain tasks. Working on something like Maya, with its large code base, I really saw the benefit of building golden paths. Because over time, it's easy to start having lots of different ways to say, retrieve data from a node graph. It starts with one implementation, but then somebody wants to do that in a slightly different way, or the original classes are not accessible from another area of the code. So then a second implementation is added. The problem is, the more ways to accomplish a task, the more permutations there are to test. And it becomes insidious, trying to keep track of all the different paths and where they are used. And updating the feature means updating each of the different implementations. And this is a problem, because code maintenance, it's a thing. My recommendation is to use and enforce a golden path wherever possible. With large commercial products, having a communication channel with your customers can be difficult. For example, the Maya team is not part of a film or VFX house. For the most part, the development team is made up of programmers, which is why highly skilled artists are hired as designers to bring the client perspective to Maya. I've always thought that this is one of the key reasons why Maya has been so successful. My thoughts on this were very inspired by this quote from David Bowie. The most interesting thing we were doing at the time actually was working with synthesizers, but throwing the manuals away. Because these things are programmed by high-tech buffs who have no idea what can be done musically. This resonates with me because I have no idea what artists do to create art. I mean, I have some vague understanding that it involves imagination and stuff. Yeah. But I cannot be expected to speak to the workflows that artists have. So there's a real advantage to having a person hired specifically to speak as the client representative. These people are selected for their ability to speak concisely, clearly, and to provide insights into why the customers need what they do. But even with the in-house designers in Maya, it was always such a treat when any one of us would get sent to a film and VFX house. And when someone else would come back, for me, it almost felt like, oh, did you get to see an artist in their native habitat? As much as I loved working on Maya, I eventually made the difficult decision to leave and stay at home with my kids. And when my kids went back to work, went to school, no child labor. Maybe some chores, but no child labor. It was time for me to come back to work. After working on Maya for so long, I wanted to try something different. It just so happens that I have been playing video games since the early 90s, and I wanted to work in a place with artists directly around me because in rendering, the client is the artistic vision. So joining the games industry was a natural fit. But the irony of having all the artists around is it can still be tricky finding the right people to represent the artistic vision, because you need someone who understands not just what artists are doing, but why they are doing that. In games production, these two groups of key people are who I look to speak from the rendering client perspective. The art directors. They supply the vision, the overarching goal. Technical artists and their leads. They confirm why artists do things and what workflows our tech needs to support. One of the key things I have learned in my time in games, turning artistic vision into actionable items is a talent. From the rendering side, this requires understanding what are the elements of an image that impact us most. Now, has anyone ever seen the YouTube channel First We Feast and their series Hot Ones? I see some nodding, but it's totally fine if you have not seen it. That's not a problem. The important thing is that in the series, they discuss the idea of the big, little details. These are the small details that almost at a subconscious level influence our perception of quality. and knowing what small details matter is a talent, and it's very underrated. For this part of the talk, I'll be discussing games productions that use bespoke game engines. These are game engines made for a specific game and any subsequent releases of that game. All the programmers are a key part of the game production team, and the line between the game engine and the game production is fuzzy at best. And that's because everything is focused on shipping the game. And to that point, game systems are also tuned to support the game's specific player experiences and art content types. And if the intention is to create a more general feature, the immediate use is actually still just going to be driven by the needs of the production, because the prime directive of the entire team is to create an incredible game and ship it. There are some fundamental differences between software products and video games. Contrasting these two development environments, I find so much comes back to the different purposes they serve. Software is used to get something done, whether it's casual apps on our phone or career software like Maya. The software is there to help customers create or achieve things. Workflow improvements are key because the goal is to make the user feel productive. Games, however, are entertainment. Workflows should not get in the way, but that's because they don't explicitly drive the value of a game. Remember that on Maya, we had a release that was dedicated entirely to workflow improvements. Could you imagine if we had a game release like that? The reviews would be hilarious. It was like the last game, but I clicked less. For games, the goal is immersion. It's like when I was playing Horizon Zero Dawn, and my husband came down in the middle of the night, and he's like, "Are you ever gonna come to bed?" To which I had to explain to him that the monster had just busted through the village wall. There were all of these townsfolk, and who was gonna save them if I went to bed? Because for me, in that moment, I was in it, and the game was alive for me. And that's the goal of games. As what we want is to give to our fellow gamers moments that they don't want to put down. Because the goal is immersion, many of the tech systems are meant to blend into the background. For much of the game systems, the hope is that players don't even realize they exist. Think about it. When there's a really great game, you will hear players and streamers rave about things like how much fun they had, how beautiful the game is, or how the narrative and characters captivated them. But you will never hear anyone comment on, say, the data loading tech, unless it's to complain because it broke their immersion. It was so bad. For much of the game tech that we write, the desire is that players don't notice all of the work that we've done. So why do we go to all of the hassle? Because we know that things like frame stutters can disrupt the player's perception of the entire game. Sudden changes in frame rates can be devastating in games that test players' timing, like fighting games and first-person shooters. Imagine you're on your third attempt at a boss battle, and you are just about to put in that last blow and win, and then there's frame stutters, and you lose track of the enemy's motion, and it's like you have to start again. That's infuriating. Frustrating moments like that can really weigh down the fun a game gives you, which is why rendering teams work so hard to avoid frame stutters and similar problems. And this requirement for smooth frame rates shapes how we pick alternative algorithms, for example. Most people know to look for the average performance of different algorithms. However, in games, worst-case performance is a key piece of data because a terrible worst-case performance can signal a risk for frame stutters. As you can see, games have very tight performance requirements, and the demands on memory is similarly heavy as well. To match player expectations, game tech needs to be hardware aware. Now, for the most part, high-level systems are protected from this complication, but lower-level systems are designed to balance hardware resources explicitly. Because of this, games are particularly sensitive to changes in hardware or driver configurations. To manage this risk, game productions will often have compatibility labs. These are labs with a group of selective machines that have representative CPUs and graphics cards. And this is important because what works on a developer machine can break on a different hardware setup. In contrast, gaming consoles have set hardware and driver configurations. They also have strict requirements for games and a formal submission process for approving the game for the console. Now, yes, officially Windows also has a submission process for getting a game approved, but it's nothing like the experience of releasing a game on a console. All this work is about ensuring that players have the best experience regardless of what hardware they play on. But one of the most intriguing things I've realized about games is how the art pipeline drives so many of the tech decisions, especially on the rendering side. I've found the tech is in service of supporting the art pipeline, not just the artistic vision. Some key context about the art pipeline. On a games product, there are far more artists and content creators than programmers. There are animators, character artists, lighting artists, UI artists, the list goes on. Tech artists and their leads determine how the data will be created so that it fits into our tight budgets. Artists need to fit their work into these constraints. And much of the artist's time is spent scaling down and adapting their creations to fit into our tight performance and memory budgets. For example, one of my favorite things on Far Cry 6 was seeing all the beautiful plants and flowers that were created for our lush world. Our biomes team would craft beautiful digital renditions of plants and trees found in tropical islands. And then the team would alter those assets so that they could create minimal memory-sized versions that were optimized to look good at a distance, look good up close, and many steps in between. And this is because we need our memory budgets to remain intact, even if there are hundreds of them placed in a scene. But the nuance that surprised me the most was how the art pipeline also impacts the way we deal with technical issues at different times in the development cycle. Let's look at the common idea of shifting left. In the traditional development cycle, the focus of testing would take place in what's known as the stabilization period or stabilization period of development. But as you can see, the cost of fixing bugs increases dramatically in the later development cycle. Nowadays, most productions aim to shift aggressively to the left, the bulk of tests earlier in the development cycle. For programmers, that means putting a priority on unit tests and automated tests. C++ programmers have some additional tools. For example, there are compile time features like const expr to get the compiler to test correctness for us. As well, we have a healthy selection of static analysis tools, such as linters and sanitizers. But the power of programming is that our changes are systemic. So let's take a look at this in the context of a games production. When a programmer changes the tool an artist uses, or say fixes a bug in how textures are rendered to screen, we change that for all artists. Which is why when an issue is found in the beginning of the development cycle, having a programmer fix the issue will often save countless of hours of artist time and labor. But this power is a dual-edged sword. Systemic changes can often have unintended side effects and usually require a testing period to rule out secondary glitches, which is why when issues are found later in the development cycle and so close to shipping, the balance often shifts to artists instead of programmers. As we get close to shipping, we'll often have artists cover up the glitches so they are less visible. When needed, we shall say we effectively art away our problems. This approach may be more costly in artist time, but it prevents dreaded unintended side effects that you cannot risk as you're about to ship. But the disadvantage to having the entire team focused on shipping the game is that the path for tech advancements doesn't always fit in the schedule of a game. Which is why it's important we talk about more generalized game engines. These are game engines used by more than one game production and are used for more than one game type. The game system needs to support different player experiences and different demands on the hardware resources. There will still be programmers embedded in each game production, but a portion of the programmers are assigned to a central team responsible for the game engine. Whether on the production team or the central team, a programmer can work on tech foundations of the game engine. But the difference is, the central team is there for tech agendas that don't fit into a game production's priorities or schedule. And having the central team ensures that there are people dedicated to the longer-term vision of the game engine. Because the prime directive of the central team is the health of the game engine. For generalized game engines, the different game productions are the clients. Game engines want a close relationship with key customers. Why spend all your time imagining how the customer will use your tech when you can just talk to them about it? As well, concrete examples prevent over-engineering. When developing in isolation, you can always tweak and tune a game engine to make it better. But working with a games production gives you the context needed to understand why certain features need to be prioritized over others. Game productions give you the data you need to make informed decisions. Successful generalized game engines that have become commercial products have been built for specific games first and then moved to generalized game engines. One of the things I enjoy about working on Maya and working with generalized game engines is the importance of longer-term thinking. Features are important, but your game engine is nothing without the right tech foundation to support it. For rendering, game features are used to bring creative vision to life. Ideally, art, content, and tech features are paired like fine wine with your meal. They are meant to bring out the best in each other. The important thing is that you avoid what I call tech salads, where a bunch of features are kind of jumbled together but fail to build on each other. The goal is to put together a cohesive whole. A good example of a cohesive whole for me is the sunsets in Far Cry 6. The clouds, the atmospheric scattering, which is that signature orange-red tone of the sunset, the oceans, all of those build upon each other and enhance the beauty of each other. The sum is worth more than the parts. In contrast, there is tech foundation. If you were to imagine building a game like building a house, the game features are the light fixtures and the taps, whereas the tech foundation is the wiring and the plumbing. If all goes well, the person who lives in the house will never see those things. It's the tech framework you build other features on. In games, an example of critical tech foundation is geometry and texture streaming. When you cannot fit everything into memory at once, you need to have an efficient and reliable way to move data in and out of memory as needed. I want to give many thanks to Cindy JB for giving me permission to use this image that they captured using the photo mode of Far Cry 6. Photo mode has been such a delightful way to see what captivates players most. And for feature development, it's tremendously important that a game engine team has a close relationship. Oh, did I go backwards? No, I went forwards. Okay, close relationship with key customers. I did mention that point before, but I'll mention it again here because you can do some early testing with placeholder data. Games have entire teams dedicated to create rich and diverse data sets to populate entire game worlds. For visual appeal and testing quality, programmer art just can't compete with a game production's vast data set. Also, you can try some isolated testing or prototyping, but when the game is running, there are so many systems all interleaving and running together at once. For example, at any one time, if you are playing Far Cry 6, you will have the UI systems running to provide feedback to the player, AI systems to bring the world to life, and the streaming systems to proactively load and unload data. This is so that you don't run out of memory crashes. And these systems, amongst others, all need to share the same hardware resources. So what works in isolation might break with the game and all of its content loaded. Which is why nothing tests a feature like a game engine. In this case, you could think of the game engine as an operating system that ensures each different game system plays well with each other. And each game engine enforces certain rules about how to request resources and how to ensure key timings are respected. Game engines are not isolated islands. They need to fit into a much larger tech ecosystem. There is a wide and well-established ecosystem of products for creating game content, like Substance Designer for textures, Wise for audio, Maya for rigging. It's interesting for me that Maya is considered a digital content creation tool in games. And it makes sense, because most games only use a limited set of its capabilities, such as modeling or rigging. But in film and VFX, Maya is actually usually considered a platform. Film and VFX houses will build tools that plug into Maya and make Maya the backbone of their entire pipeline. This is more like a game engine that becomes a platform that takes in content created by other applications. Game engines will have tools programmers dedicated to ensuring that content created in other applications can be processed into a format the game engine can use efficiently. Because a big driver of quality is the game engine's ability to work well with content creation tools. When software products games and game engines are successful, their development needs to scale over time and team size. Process is key to handling scale and complexity. Now, when we talk about formalizing processes, it can inspire a worrying image of a dystopian future where nothing gets done without crossing miles of red tape. But that's not actually the goal of process. Think of it more like getting a table at a restaurant. Whether I'm in Korea, Colombia, France, or Canada, I can walk into a restaurant and without thinking, get myself a table. Because the process of getting a table is so well understood and universal. Set processes allow us to forget the repetitive parts. And instead, we can focus our efforts on key strengths. Restaurants don't have to innovate on how their customers will find a seat. They can put their creativity into what people care the most about, the food and the ambiance. But how does this focus on process play out in the context of creating tech? Clear processes are key for ensuring smooth handoff points. In AAA games, we know that formalized processes save time when passing work from one team to another. Motion capture data is passed to animators, then to cinematics teams with their lighting and character artists. You don't want to keep circling back because someone forgot to include details that they may not have even realized were needed at later steps. You want nice, clear requirements up front. Similarly, large development teams use process to reduce duplication. If this isn't an area of innovation, why have different people maintaining different processes that achieve the same goal? Standard processes give us a golden path. When processes get used by large amounts of people because it becomes easier to spot the bottlenecks. It's just like in tech. You cannot optimize properly without gathering data to identify where your bottlenecks are. So when you start using a process, everything can feel kind of awkward and weird. Your data is full of noise. You need to have tried the process a bunch of times so you can identify the real problems and the real bottlenecks. And because it's a standard process, it means that everyone gets to benefit when the process is improved. Particularly for this slide, I want to credit the book, Software Engineering at Google, Lessons Learned from Programming Over Time. This book was curated by Titus Winters, Tom Manschreck, and Hiram Wright of Hiram's Law. And it helped me crystallize so many of my thoughts on this topic. I also want to thank the open source Godot game engine for the very permissive licensing they have, which fosters Godot as a source of knowledge for an entire community of people. Our time together is coming to an end soon. So I put together a list of key takeaways for you, like the primary importance of asking why. Cross-functional teams need to ask who, what, how, and why. However, in our tech circles, we need to get better at forcing ourselves to ask why and ensuring that our decisions are based in relevant data and not just opinions. Successful software products require longer-term thinking. The dream is to have a solid base so you can build on for future releases. This means an awareness of the customer needs and strategies for making changes. The dynamic quality that relates code and game content creation. In games, the tech we create allows us to immerse the players in beautiful and exciting game worlds. But it means we have the responsibility to not let tech issues disrupt the player's immersion in those games. And also the interesting that I learned that the game's vision means also supporting the art and content pipeline. And most importantly, please remember about how the wider context shapes the decisions we make. As much as we program solutions, the wider development environment specifies the types of solutions that we create. In the words of Marshall McLuhan, the medium is the message. As we move to our question period, I'm going to leave this slide up in case anyone would like to reach out and keep the conversation going after this presentation. LinkedIn is the best place to direct message me, but I post rendering-related things on the other accounts if you're curious. And before I take questions, I want to thank all of you for taking some of your time to consider a topic that is so tightly tied to my life's work. Thank you.